Welcome to Knowledge Gainer 1M channel. 11th question in the number system topic is the product of two numbers is 7168 and HCF is 16. Find the numbers. In this type of questions, we should first find out the value of product by HCF square. Substituting the values 7168 by 16 into 16. On cancellation, we get 28. Now we should find the possible pairs to get 28. So 1, 28 is first pair, 2, 14 is second pair, 4, 7 is third pair. In these three pairs, 2 and 14 are not co-primes. That is, one number is not prime to the other. So we should reject 2 and 14. Now to find the numbers, we should multiply the given HCF with the pair of numbers. So 1 into 16, 28 into 16 is one pair. 4 into 16, 7 into 16 is the second pair of numbers. Another model, a number on being divided by d1 and d2 successively leaves the remainder r1 and r2 respectively. If the number is divided by d1 into d2, then the remainder is given by d1 into r2 plus r1. Let us see a question. A number on being divided by 5 and 7 successively leaves the remainder 2 and 4 respectively. Find the remainder when the same number is divided by 5 into 7, that is equal to 35. From the formula, we should write the divisor d1 is 5. Here r2 plus r1. So here 4 plus 2 should be taken. 5 into 4 is 20 plus 2, which is equal to 22 is the remainder when the number is divided by 35. Let us solve the same problem without using the formula in a detailed way. So let the number be a. It is divided by 5 and we get the quotient as b and remainder as 2. Now b is again divided by 7. We get the quotient as c and remainder as 4. So for solving, take c as 1. Now b value is c into 7 plus 4, which is equal to b is c value is 1. 7 1s are 7 plus 4 is c we get b we get as 11. A can be written as a is equal to 5 into b. We got the value of b as 11 plus 2. 5 into 11 is 55 plus 2 is 57. Now divide the number 57 with 35. 35 ones is 35. The remainder we get as 22. Another model is to find the number of zeros at the end of the product. We get zeros at the end in two conditions. The first one is when there is 0 at the end of the multiplicand, that is 20 into 2, which is equal to 40. As there is 0 here, we got 40, that is 0 in the end. The second one is when 5 or multiples are 5 are multiplied with even number, that is 2, 4, 6 and so on. When even number is multiplied with 5 or multiples of 5, we also get zeros at the end. From this we can write this as 2 power m into 5 power n. Has m zeros if m is less than n, has n zeros if n is less than m. Let us see an example based on this model. The question is question number 13. Question number 13, find the number of zeros at the end of the products 12 into 18 into 15 into 40 into 25 into 16 into 55 and 105. First we should simplify these numbers and write in the multiples of 2, 5, 3 and so on. Add the powers of 2 and 5. We get as 2 power 10 into 5 power 6. Ignore all other numbers, that is 3, 7, 21, 11 and so on. No need of those numbers here. So 2 power 10 into 5 power 6 is taken. Here m is equal to 10 and n is equal to 6. 6 should be taken because we should take the lesser value, number of zeros at the end of the product. Number of zeros at the end of the products is 6. Another model which is very important, n is a composite number. N is equal to a power b, b power q, c power r and so on. A, b, c are prime numbers. P, q, r are positive integers. Then the number of divisors are p plus 1 into q plus 1 plus r plus 1. Here unity and the number itself are included as the divisors in the formula. Question number 14. Find the number of divisors of 50. Here 50 can be written in the form of prime factors as 2 into 5 into 5, that is 2 power 1 into 5 power 2. So the number of divisors are 1 plus 1 into 2 plus 1. 2 into 3. There are 6 divisors including 1 and 50. Question number 15. Find the different divisors of 37,800 excluding unity. Now we should write 37,800 in the form of prime factors. 2 power 3 into 3 power 3 into 5 square into 7 power 1. So the total number of divisors are 3 plus 1 into 3 plus 1 into 2 plus 1 into 1 plus 1. We get it as 96. So we should exclude unity minus 1. So the total number of divisors excluding unity are 95. Another model to find the number of numbers divisible by a certain number. 16th question. How many numbers up to 100 are divisible by 7? We can get this by dividing 100 with 7. 7 ones is 7. We get the remainder as 3. Take 0. 7 fours are 28. So the number of numbers divisible by 7 up to 100 is 14 is the answer. Another question based on the same model. How many numbers up to 200 are divisible by 4 and 3 together? Here we should find the LCM of 4 and 3 first. LCM of 4 and 3 is 12. So we should divide 200 with 12. 200 once is 12. The remainder is 8. 0. 16. 6 is 72. The remainder is 8. So the number of numbers which are divisible by 4 and 3 together up to 200 is 16. Another question, how many numbers between 100 to 300 are divisible by 7? The question is asked only between 100 and 300. We should find the numbers divisible up to 300 minus numbers divisible up to 100. Now divide 300 with 7. So 4 is 28. 2 is the remainder. 0. 2 is 14. Here 42 minus. Now 100 should be divided with 7. 1 is 7. 3 is the remainder. 4, 28. 2 is the remainder. 14. So 42 minus 14, which is equal to 28. So 28 numbers are divisible by 7 between 100 to 300. Question number 19. Find the number when multiplied by 16 is increased by 220. Let the number be x. When this x is multiplied by 16, it is increased by 225 than the original number. So we can write this as 16x minus x is equal to 225. We get as 15x is equal to 225. On cancellation, we get x is equal to 15. The original number is 15. Let us see some formula based on the sum of the numbers. Sum of all the first n natural numbers is n into n plus 1 by 2. Sum of all the first n odd numbers is n square. Sum of all the first n even numbers is n into n plus 1. Sum of all the first 105 natural numbers is, according to the formula, n into n plus 1 by 2. Here n value is 105. So 105 into 106 by 2. On cancellation, we get 5565. Find the value of 1 plus 3 plus 5 and so on till the 20th odd number. The formula we should use here is sum of all the first n odd numbers, that is n square. Here the value of n is 20. So 20 square is 400. Next question. Find the value of 2 plus 4 plus 6 plus 8 and so on till 100. Here n value is particularly not given. In the question only the sum of the even numbers is asked till 100. So n is equal to 100 by 2, which is equal to 50. From the formula the sum is n into n plus 1. So 50 into 51, we get the value as 2550 is the sum of all the even numbers till 100. Two more formulas. Sum of squares of first 10 natural numbers is n into n plus 1 into 2n plus 1 by 6. Sum of cubes of first 10 natural numbers is n into n plus 1 by 2 whole square. Question number 23. Find the value of 1 square plus 2 square plus 3 square plus so on till 10 square. Here the value of n is equal to 10 should be taken. So from the formula n into n plus 1 into 2n plus 1 by 6, as n is 10. 10 into 11 into 2 into 10 is 20 plus 1. 21 by 6. From cancellation we get the value as 385. If 1 square plus 2 square plus 3 square and so on till 10 square is equal to 385, find the value of 2 square plus 4 square and so on till 20 square. Now we can write this as 1 into 2 whole square, 2 into 2 whole square, 20 can be written as 10 into 2 whole square. Take 2 common out, 2 square into 1 square plus 2 square plus so on till 10 square. The value of this is given. So 2 square is 4 into 385, which is equal to 1540. In the first n counting numbers, if n is even, there are n by 2 odd numbers and n by 2 even numbers. If n is odd, then there are n plus 1 by 2 odd numbers and n minus 1 by 2 even numbers. Question number 25. From 1 to 50, there are how many even and odd numbers? From the above formula, there are n by 2 even numbers and n by 2 odd numbers. From the above formula, the odd numbers is n by 2, which is equal to 50 by 2, which is equal to 25. Even numbers is also 50 by 2. That is 25 odd numbers and 25 even numbers are there. Question number 26. From 1 to 51, how many even and odd numbers are there? Here n is 51, which is odd. So the number of odd numbers is n plus 1 by 2. 51 plus 1, that is 52 by 2, that is 26 odd numbers. Number of even is n minus 1 by 2. 51 minus 1 is 50 by 2, which is equal to 25 even numbers are there. If you like my explanation, please like and subscribe to Knowledge Gainer 1M channel and share with your friends.